in this lesson, we're now going to take a look at a couple different ways we can set up proportions. Okay, so if you didn't know, this was called a proportion. How can we set up a couple different proportions to solve for missing sides of triangles? Okay, so check this out. Let's say the first thing I do, I label my sides, right? So VW is 14, YW is 6, XZ is 8, and then I need to find the X. So since I'm trying to find this, I am going to use an X to represent it. You can use any other letter that you would want to use, but this is what we're trying to find. This is the length of this particular side. So to solve this, we can set up this really cool proportion that says I can simply just take 14 divided by 6 and set that equal to 8 divided by, X divided by 8. So 14 divided by 6 is equal to X divided by 8. And it's kind of set up so perfectly so that we can easily see that this makes a fraction. This goes in the numerator, this goes in the denominator. Now this is equal to, this goes in the numerator, this goes in the denominator. Okay? And then we would do, like we've been practicing, just cross multiply to solve. So we do 6 times x, that gives us 6x. And then 14 times 8 is 112, and then divide both sides by 6. So I get that's x is 18.6 repeating, and if I was to round that up, let's say to the nearest tenth, well, if I have a bunch of 6's, right, this 6 would round up, so then this would become a 7 here. If I was just rounding to one decimal place, so 18.7, if I round to the nearest tenth. Cool, so that's one way that we can use proportions. So simply set them up in two fractions and set them equal, cross multiply, okay? We can also use another strategy when we're doing proportions. So let's say we have these sides that we're given instead. So VW is 12, okay? And then YW is 5. VZ, okay, so check this out, from V all the way to Z. So I really want to be careful that we understand it's from here all the way to here. That whole entire distance is 20. And then we just need to figure out the distance from V to X, which is just from here to here. That is our unknown now. Now we know this whole thing is 20, and we're just trying to find this small little piece here, okay? Well, if we're trying to solve something like this, again, our strategy here is going to be to take VW and divide that by VY, okay? So now I'm not going to just take 12 and put that over 5, but instead I'm going to take 12, okay, and then divide that by the whole entire side here, V all the way to Y. So what is the distance from V all the way to Y, okay? Well, that's going to be a combination of both of these. So 12 plus 5 is 17. So I would put 17 in the denominator. So why am I doing that? What's the strategy here? Why do I care about doing that? So let me back up just a little bit. And if I highlight this, maybe we can kind of see what's going on here, okay? So I'm taking this 12 here, and I'm matching that up. Let me fix the highlighting. And I'm matching that up with this 17. Let me move this over just a little bit so we have some more room to work with. So I'm taking this side that's 12, I'm matching that up with 17. I put that in a fraction together, so the green part and the blue part there. And then check this out. I'm going to set this equal to, on the other side of this triangle, again, the green side, which is x, divided by the blue side, which is 20, okay? So if you can look and see the pattern that I'm using here, so I'm doing the green side over the blue side is equal to the green side over the blue side, okay? So this is one other strategy that you can use to solve for missing sides in a triangle, okay? When you have a particular problem like this. So let's start solving. So we get 17 times x, and then 12 times 20, and that gives me 240. Divide both sides by 17, and I get that x is 14 point, and I'll round it to the nearest tenth, 14.1 for this particular problem, okay? Meaning, I was trying to find Vx, right, and I should have clarified that up here, that this x we're symbolizing as Vx, so Vx would be 18.7 for this last problem, and then same thing, the Vx, or side Vx, is 14.1, okay? Okay, now let's take a look at this next problem. And it doesn't really give us any hints for this one, like this last one, it was giving us a couple hints for how we could set things up. But this one, it kind of just leaves us on our own. Okay, so let's just label the sides to see what we have going for us here. So that's 10, NM is 4, and then JL, okay, that's from here. And I like the highlighting a little bit better, so let's do that instead. So if I'm highlighting this, so J all the way to L is 6. Okay. Find KL. So from K to L, that's just that distance there. We don't know what that is. Okay. So using kind of the trick that I showed you from the very last problem, okay, I showed you how Vx matched up. It was like the same color as the VW that was over here, okay? So using that idea, KL, if I was to highlight some side on the other side of this triangle, what do you think KL would match up to? So if you're thinking 4, that would be correct. Okay, so KL is going to match up to this NM over here, okay? Well, what about the blue part? Okay, well, the blue part is the whole entire thing, so that means for the other side of this triangle from here all the way to here, that is now going to match up, okay? So that entire distance would be the combination of those two. So 10 plus 4, 14. So that whole entire side is a length of 14. All right, so here's how I set this up in a fraction, okay? So I can do the green part, so which is x, from this side of the triangle, so x divided by 6. And since I'm picking the green part to be in the numerator, again, when I come over to this side, the green part has to be in the numerator as well. So 4 has to go in the numerator, and then 14 in the denominator, okay? And simply cross multiply to solve, so I get 24 equals 14x, and then divide both sides by 14, and I get 1.7, okay? I quickly want to show you one other thing that's actually a little bit cool about this problem. I could solve it using a different proportion, so you don't necessarily have to do this one. Let's say that I put the blue part in the numerator instead. Okay, let's say I put 6 in the numerator, and the green part went in the denominator. So 6 over x, and then same thing for the other side, 14 goes in the numerator, 4 goes in the denominator. Would I get the same answer? Okay, so if I do this, I get 14x equals 24 and divide by, oh my gosh, I got the same exact answer. Okay, so there's more than one way that you can correctly set up these problems, okay? And the last thing that we will look at is not necessarily a problem, but it's just a theorem that you'll end up using within the notes. But it says, okay, an angle bisector in a triangle divides the opposite side into 2 segments. Okay, so if you don't remember what an angle bisector is, that's from the very first unit. Okay, so BD right here would be the angle bisector. Okay, the angle splitter. So it's taking this angle, which is one giant angle, this whole thing, and it's just splitting it in half right down the middle, dividing it in two, okay? So that's what an angle bisector is. It just cuts an angle in half. And it also is going to divide the opposite sides, right? So the opposite sides are talking about AD and CD right here. So this AD and CD is going to split that side into two pieces, this blue piece and this purple piece. And they're actually going to be proportional to the other two sides of the triangle. So check this out. This AD right here is going to be proportional to AB, and the DC is going to be proportional to BC. So if you were given numbers for these sides, you could set them up just like they're showing you here in this particular fraction if you're plugging everything in.